Hello, hello. Welcome to today's webinar. I'm really excited about this one. Welcome, everyone. We have a tremendous crowd on this webinar. Lots of developers, a good number of architects. Looks like we've got some technical managers of various sorts. Lots of great job titles. And so we are going to try to be respectful of your time. There is a lot of information to cover. We've blocked out an hour for this webinar. We like to run ahead of schedule because we know that everyone is busy and has a lot of stuff going on. And so we're going to go ahead and get started. Today's topic is on BlazorMVC. And this is Blazor is new. We'll get into that. We'll also get into, wait a minute, MVC. I thought that was something different. And for those of you who have not been on a ClearMeasure webinar before, this will be exciting for you. A little bit of introduction. ClearMeasure is a Texas-based software architecture company serving the entire United States, and we're empowering software delivery, enabling in-house .NET teams to be self-sufficient, able to move fast, deliver quality, and to run their systems with confidence. So our clients are .NET development teams who want to do more in-house, don't want to outsource, don't want to go to recruiters and just have them provide contractors for a period of time. We also are hiring, so you can go to clearmeasure.com/careers and learn more about that. Another resource you may be interested in is a podcast that we run. It's called the Azure DevOps Podcast. And if you just go to azuredevops.show, you can see all of those past history of interviews and shows and show notes, lots of great topics. And a free offer coming up next, not related to Blazor. I don't have my Blazor book out yet. We're doing presentations and samples and whatnot. But if you are interested in my latest book, .NET DevOps for Azure, you can get a free electronic copy just by sending me an email and asking for it. And of course, you can get the print book anywhere print books are sold. So just go ahead and send me an email. My email will be back up. And if you can ask a question in the Q&A window. All right, we're going to get right along with it. If you use the Q&A window in Zoom, you can ask me a question. I'm pretty good about answering questions while we go through the material. And but I do commit that if there are any questions that are still yet to be answered, I won't end the webinar until I've answered those questions, even if that means that you and I need to have a one-on-one conversation just so I can make sure that question is answered. And speaking of that, people ask anyway because I give out my email address. If anyone does need some one-on-one help, just send me an email. That's cool. Love that. All right. So let's talk about Blazor and MVC and what really is called BlazorMVC. First off, why do I care? Why do I care about MVC or model view controller patterns? Now, way back in 2009, I think it was, I really jumped onto the model view controller pattern and specifically the ASP.NET MVC framework when it was first coming out, even before it was released. And so I wrote, actually, this is my first full-length book, ASP.NET MVC in Action. And then there was a version 2, and then we did another sequel for version 4, and then did a series of live lessons with Pearson Education for ASP.NET MVC 5. And then one of the books was translated into all kinds of different languages. But the model view controller framework, the model view controller pattern was new for a lot of .NET developers at the time. 2009, wow, that's 12 years ago, 12 years. It was new for a lot of the people in the .NET community. Now, the .NET part of the industry has grown so large that in the last 7 years, we've doubled. And so probably half of you, well, if this call is representative of the industry, which it's not, because I know that all of you are more serious about your careers, you're more serious about learning. That's why you come to things like this, and that's why you're learning. But probably half of you might not have been in the industry 7 years ago, perhaps. And then of course, we got quite a few old timers and certainly I fall in that category, but the model view controller pattern is really, really old. It harkens back to the small talk language and back in the 70s. So it's not a new thing, but there's a lot of people who do .NET development that don't use model view controller. But I went deep into that pattern and the implementation, starting 12 years ago with this book, actually a few years prior. And I really do care about it. And so when Blazor came out, I thought, you know what, there's something here. Now, again, with ASP.NET-MVC, there's a popular open source library called MVC Contrib. And I was one of the co-founders of that, along with Eric Hexter. And there's various versions of MVC Contrib that are out there, and you can see, almost 1 million total download. Actually, if you add up all the different versions together, it's over $1 million downloads. And I, for one client's project, we were looking at interaction models with a pretty substantial Blazor implementation. And I thought, there's a pattern missing in this Blazor framework. Blazor is fantastic and all. This is not an introduction to Blazor talk at all. Actually, I expect that every one of you have already done a few Blazor projects, even if it's just for yourself. You've done, file new Blazor project, hit Control F5, run it, made some modifications. You kind of know the ins and outs of Blazor. So we're not going to introduce that here. But in the Blazor framework itself, there is a little bit of a wall you hit once you start decomposing complex screens. And once you start thinking, wow, I need to click on a button over here on the left side, but I need 2 other components that are somewhere else on the screen. I need them to respond to that. And I need them to be aware that they're working together. And I need decision logic to be separated from logic that merely lays out and formats elements on the screen. And so I kind of implemented a model view controller pattern on that Blazor project. And then I looked at it and thought, this really should be baked into the product. It'd be my first choice. And and I hope that that'll one day happen. But in the meantime, I created the open source library, BlazorMVC, because anybody should be able to just drop this in and start using a model view controller pattern in your Blazor applications. And with all my past experience with different types of model view controller, I thought, this could help people. So I did that. So you can go on NuGet right now. You can search for BlazorMVC and you can download the latest one that has samples in .NET 6. And there's samples with .NET Core 3.1, .NET 5, .NET 6, server-side Blazor, WebAssembly Blazor. You can also go and get the code directly from GitHub and just implement the pattern yourself. That's the great thing about open source projects. There's nothing that says you actually have to use the binaries straight from the NuGet package. Certainly that's easy to do. But if you want to just go and look at the code and say, well, you know what? I don't want all of this, but let me just pull in part of it. Well, that's fine too. Go and grab the code. So that's what I did. Now, let me back up and talk about model view controller just a little bit from a high level for people who might not have been around for the ASP.NET MVC wave. Like I said, it's an old pattern, but in the model view controller paradigm, the user input, the modeling of the external world, and the visual feedback to the user are explicitly separated and handled by 3 types of objects, and each of them specialized in its task. So this is important. Model view controller, there's 3 different types of objects. Every screen or every element of a user interface has these 3 objects. And so the view manages what you see. The text output, in Blazor, the HTML, and CSS, the layout of things. The view manages what you see. The controller interprets what you do, your input, and then decides how to interact with the model and the view. So the controller is the brain. The controller makes decisions, okay? The model is the last one. The model manages the behavior and the data of whatever application that you're using. And by extension, the model is probably part of a larger domain model or sets of aggregate roots if you're using domain-driven design language, and the rest of the application. So to drill it down, if you're going to separate these things out, you look at a line of code and ask yourself, is that line of code deciding what I should be doing here? Or is that line of code laying out and formatting something so that the user can see it? Okay. And then sometimes you see a button where, oh, the button needs to be painted on the screen. It needs to be there, but clicking on the button, oh, control needs to go back to the controller, because the controller needs to make the decision about what a click on that button actually means. All right. So, so that's model view controller. And by the way, you can implement this on your own if you like. All right. All right. So overall, back to the problem I saw with just implementing regular Blazor applications is we end up getting the good old spaghetti code. We end up getting a situation where we have screens that have a lot of HTML in them. And of course, we have a lot of CSS classes. Those are factored into CSS files. So that's managed pretty well. But then we have little bits of C# that are intermixed with the view. And then we have all the event handlers and the lifecycle events and all of that mixed together. And we start to have an object that's actually got more than a single responsibility. So that's the first of the solid principles, single responsibility principle. And so this is also just regular object-oriented thinking. Now, that will also cause you to decompose a Blazor component into multiple child components, but then the child components need to be managed by the parent component, okay? So now you start thinking, okay, well, where the child component goes, that's a layout decision. That's deciding where on the screen it should go. But then we have code that has to tell the child component to do things at certain times, or subscribe to some type of notifications from the child component. So we quickly see that what emerges is code that is deciding what the appropriate thing for the software to do is. And then there's code that just lays things out and formats things so that they visually look like they should. So it's not hard to go in and identify what is view logic and what is controlling logic. So what we have on the screen here is the counter component, which is in the getting started template project of Blazor. Everybody who's done it has seen the counter component. And this has been actually refactored to use BlazorMVC. All right. I'm not going to show you the guts of BlazorMVC just yet, but this is kind of what it looks like. In the bottom right-hand corner, let's look at the view first. Instead of inheriting from component base, we have some new base classes that, of course, inherit from component base. We have a view component base, and it has all of the markup, and then it has some data tags where these go, where the model goes, where on increment goes, and I've added one, which is time, which we'll use a little bit later. And then on the top left, we have a new class called counter controller, and that inherits from a new base class called controller component base. And there is a version of this base class that is generic that receives the type of its view. Now, this is a controller component base. There's also another version of this base class that is not generic, because it's a very valid scenario where a controller does something, inspects something about the model, and then chooses view A over view B. I mean, that's a very valid scenario that happens a lot. And if you are already in a view component, or you don't even have the separation, if you're already in a component and you're looking at the model and you're executing things, and then you need to show one version of the screen, behind one if statement and the other version of the screen behind the else. Well, now you either have to have both of those, both of the markup for that in the single component, or you have to have, two children and you hide one and you add the other. And ultimately it's messy code, when in reality, these are different concepts. So we have it here. Now, I hear some people have said, well, wait a minute, there's a mechanism of separating the code from the markup. You can have the code behind file. And for people who might not have done these types of applications before, web forms, the original web framework of .NET, used code behind files, but even now, WinForms and WPF also uses code behind files. And that's great for separating the type of code into two separate files on disk so that we as humans can look at it. But at runtime, those two files are really just, think of them as just being concatenated together, compiled together. Now, in reality, with the older frameworks, instead of using partial classes, they actually were, one inherited from the other. But regardless, they end up being the same object at runtime. Okay. And so if it's the same object at runtime, then it is one thing. So the power of separating these two concerns is that the controller gets on the call stack first. All right. The controller gets on the call stack first and does some queries, receives some input, and then decides what the right thing to do is, and then decides what view should I use. Now, in a lot of cases, a particular component or controller component is only going to have one view. And so really it's deciding what data to pull, what behavior, and then push it over to the view. Notice the view is super simple, and the controller actually owns the route. Now, the controller has no markup whatsoever, but it is a full-blown Blazor component. Any class that inherits from component base is a Blazor component. Okay. And so the base class is what we're doing under the covers is the controller component has no visible layout whatsoever. It just kind of has an empty, has an empty bucket as far as visible controls. And then it takes the view, and the view becomes its single child control. And so in effect, the view is being embedded into the controller component for the purposes of the Blazor framework. And then the view has the visible elements. So even though the view is a child, becomes a child of the controller, because the controller has no visible HTML elements of any kind, the markup that you see rendered in the browser only comes from the view, but the route is controlled by the controller. And of course, when you have the @route symbol under the covers, when Blazor compiles everything, it just compiles it to that route attribute anyway. So this is the first class routing system. Okay, so why, again, do we even want to do this? Well, a lot of you have seen the Blazing Pizza application that has been a part of a lot of demos, and it's a great demo. It really is. You can select your toppings, you can make an order. It's a canonical, e-commerce sample of decomposing things. But for anybody who's gone and looked at the source code of that application, you can see that some of the code files, you have to scroll down and you can see that those code files are only going to grow from there. There's code files that have, a decent amount of C#, a decent amount of markup. It's a great example. It's a great example. But real applications are a lot bigger than this type of application. Real applications, the number of lines of code is orders of magnitude larger than this type of application. And already we can see some of the signs where it would be a lot cleaner and we wouldn't trip over it as much if we separated the view code from the screen logic code, the controlling code. And so anytime code files get large, you start to look at refactoring. Now, Blazor allows us to refactor just components, but adding the model view controller pattern as just a general type of separation of concerns in any application with a user interface is typically a good idea. So if you haven't ever looked at the source code of this, just as a good example, again, it's a fantastic example to show you how to use Blazor. And perhaps somebody might take on the challenge. And if you do, just send me an email, take on the challenge of taking the Blazing Pizza application and refactoring it to BlazorMVC just to see what it would look like. And you can see the Blazing Pizza source code at this URL on GitHub. And again, my point here is this is as simple as it gets. It only grows more complex from here. All right, so let's talk about scenarios with inherent complexity, and then we'll get into showing more code and switching over to Visual Studio. All right, why model view controller? Okay, there's going to be quite a few scenarios where the screen layout is different based on user input, and so if we look at the sequence diagram on the left, we can see that the user just loads the controller. The controller maybe looks at it and say, hey, is this mobile? Is this desktop? Is this something else? And if it's desktop, load the desktop view. If it's mobile, load the mobile view. And we might want to switch. All right, I already covered that. Now, some of you out there are going to say, oh yeah, you can use viewports and media types and all this CSS stuff. That is true. CSS can hide what it's there, but CSS cannot go and retrieve something that is not there. So if something needs to be there for desktop, because mobile is typically smaller, we might not even want to load stuff. If we load all of the desktop markup and everything, but then merely hide it and just don't show it on mobile, that's really wasteful. That hurt performance, and that's just unnecessary, and it's confusing. So when you have totally different layouts, you want to load one versus the other. All right. Another scenario is that your screen layout may be different based on the data. And so this is an example of a auction application. And this is actually a real Blazor application. Actually, this is one, I'm not sure if it's yet on the .NET Showcase or not, but you have a situation where the swine on the left is taking bids, competitive bidding. The lamb on the right is not actually up for sale through auction bids. It's only taking donations so that little girl can buy a lamb and show it at a fair next season. And so these are different lot types in an auction. They're totally different. The behavior is different. The fields that they have in it is different. What you can do as a user is different. All of the business logic about how you can interact with these two different lot types in an auction is totally different. So we need to treat them differently. But when we lay them out on a layout grid together or on a screen with 10 other lots on a browse screen, we need them all to go into the same collection of components, but that component needs to be smart enough to evaluate the model and then do completely different things and choose a different view, because the nature of these things is different. We don't just want to rely on CSS. These are actually different things, okay? All right, another scenario where model view controller helps is with parent-child or with parent layout interaction. So you have a parent and it needs to tell a child what to do, or you have a parent that has a child component that, by the way, is probably going to be decomposed into a child component, which is probably going to be decomposed into a child. I mean, in Blazor, you've got all kinds of nesting of decomposition. The nature of the framework is to decompose a screen into just tons of small components. I mean, if you have menu items or special purpose buttons, sometimes the logic of those buttons may have behavior of its own. And Blazor has layouts. So if we have a top masthead, the top of the page, or if we have a left-hand column with certain things, or maybe the bottom has some command or status areas, those are components that are going to be added to that part of the layout. So regardless of what parent page we're on, those components are going to be there. And so we need a mechanism of communication between that. And we do not want to rely on just .NET's multicast events that rely on delegates, because then we are strongly coupling these components to each other. And it's so easy to accidentally have memory leaks with which ones the Blazor framework cleans up from a memory perspective, and which ones actually still have a reference because of a delegate and all that kind of stuff. But you need this interaction. Let me take a pause real quick and tell you about a case study, which I would love to find again. But this is one thing in my early education. We studied a case study that was shared from how the Adobe Photoshop engineering team did UI architecture for the version of Photoshop in the late 90s. Yeah, Photoshop has been around, that long. Actually, my copy of Adobe Photoshop 7 still installs and works properly on Windows 11 to this day. And it is, it's very different, but it's not that different from the latest version of Photoshop. It's interesting enough. But anyway, they had a UI architecture paradigm where they used model view controller, and they made every element of the screen a controller view pair, on down to the toolbar buttons and drop down menu items. And for instance, the edit menu, cut, copy, paste, they made the copy controller responsible for knowing if the copy menu item in the toolbar and the edit menu, if it should be enabled or disabled based on if something copyable was currently selected. And so if a complex piece of software like Photoshop lands on that, more than 20 years ago, then that's saying something. And some of our applications, well, very few of our applications are going to get to the level of decomposition or complexity that type of screen has, but that doesn't mean that our applications are not going to still be decomposed quite heavily. All right. Another scenario that we need to cover is one-to-many UI events. All right. So we have the user selects an item in the middle of a page. Well, there's a component in the middle of the left bar of the layout, and it needs to be aware of that. It needs to do something. And so there needs to be a communication mechanism across these components, because in decomposition, all these components need a notification mechanism, but the view doesn't need a communication mechanism. The view should not know, and this is kind of a part of the model view controller pattern. The view should not know what controller is using it. And I'll switch over here. This is the dependency. Actually, before I do that, let me just make one more point. The view doesn't know what controller is using it, but the controller knows and chooses its view. And then the controller coordinates with other controllers around the application, around the current screen, not because it knows the type per se, but because it passes around its model or new models. And model is a generic term. Certainly there are models that pretty much look like one record of a database table. They are data holders and they have behavior around the data. But there's other models that are never persisted to a database. There are models which could purely be events that the application uses. And certainly, something, an item being selected, well, that's an event. And that model, that event model, can be passed around and used. So there are all kinds of different models based on your application, not just ones that Entity Framework persist to the database. All right. What if there are other patterns that could solve this problem? And let's talk about one of them, model view presenter. This is another pattern that has kind of been around for a while, and it was actually pretty popular with WinForms and web forms, more than a decade ago. It was popular. And the difference there was that the view came onto the call stack first, and then constructed, and then delegated to another class, a plain old C# class, which was called the presenter. And then the presenter went and got data and then passed it back to the view. So the view came onto the scene first, had a helper and a presenter, and then all the logic code was just moved to the presenter. So that's how that was. Also, still, decently popular today is model view view model. And this was made popular with WPF, and then the XAML frameworks like in Xamarin and Xamarin Forms. So model view view model is pretty similar to model view presenter from a call stack perspective, where the view comes onto the screen first. We delegate to another class, and this one's called the view model because the view model not only has behavior, but it also has properties that the view can bind to so that notifications flow back. But the view model then talks to the applications model for querying from the database and persisting things. But these two both share the same flaw, in my opinion, and that is the view enters the call stack first. All right. I think model view controller corrects that because the controller comes on the call stack first. All right. So let's talk about the coordination mechanism between all these components that are separated into controller and view pairs, and then we'll get into code. So Blazor is going to call on initialized on any particular component. And so if we have some conduit of communication, I'm going to call it a bus because the bus pattern is really, really old. And if you're not familiar with the bus pattern, just a quick internet search and you'll have a wealth of information. All we have to do is register with this object that we call the bus. And then anybody else that tells the bus, hey, pass this around, well, the bus will oblige. The bus will pass on the notification to whoever is registered. And so just by saying, hey, register me, bus, well, the bus keeps a collection of objects who are registered. And then any object can send an event, send any old C# object as an event to the bus and say, hey, please notify. And then through a little bit of easy filtering, the bus goes down, and for each of the objects that are on the bus, it basically asks, hey, are you interested in this type of event? Yes, here you go. Or, oh, no, you're not. Okay. And it goes on to the next one. And by the way, if anyone's interested, if code really talks like that, it really does. It has really intense conversations with itself. And sometimes it has funny voices. But yeah, code, I love to personify code. So the components need a mechanism like this to communicate. And so BlazorMVC provides that. All right, so now let's look at some basic code. Okay, this is what your startup code is going to look like. Super simple. If anybody's looked at the Blazor template before, it has a root component. We have to give it a piece of the name of an HTML element, default #app, but we have to give it the name of our root component. Well, that root component, guess what? Yep, we separate that also into a controller and a view pair. So in this case, we swap out for app controller. Now you see the line of code above, we add scoped the interface UI bus. That is provided by BlazorMVC. And so if you're going to use it, just add that to your startup code, and you can add whatever logger that you want in there, whether it be Log4Net or anything you like. All right. So again, you can download BlazorMVC here, and let's switch over to another screen and just look at this particular NuGet package in action, and what the code looks like and how the behavior is. So I'm going to share this other screen. Okay. So now we're sharing this particular screen, and I've gone into app controller, but I've got a commented line of code. I'm just gonna kind of show you the layout of BlazorMVC. Now I'm literally showing you the .NET 6 sample that we have in there, the WebAssembly.NET 6 sample in the source code. So here's the BlazorMVC framework, the open source library, and it's pretty simple. It doesn't have a lot of code. I'm not going to show you the innards of this just yet. I'm going to show you how it works. But this is, you can see that we have counter controller, counter view. This is basically the file new project template decomposed into controller and view pairs. But I'm going to Control F5. I'm going to run this and show you a few new things that have been added. So counter, yes, of course, we can do this, okay? And fetch data, it has that, but I'm going to add an event. I'm going to click on this, and upon click, we add a new child component, which wasn't here before, and we've passed some data to it, freezing, because we passed some data freezing. Now, this is just parent-child stuff. Click on here, click on here, click on here. That's child's play. Let me go back home. Let's click on add another child. Now we've dynamically, because again, somebody argue on this call, oh, you could do this stuff with just vanilla Blazor. You know what? You can, but I'm highlighting scenarios that really fall into spaghetti code world if you don't separate view code from controlling logic, okay? So I'm adding literally however many counter controllers I want. These are all separate. Each one has its own state. The current count's 11 on this one. And so it's totally different. It's totally different. And if I go here and then come back, well, it's gone, because every time you navigate to a different page, the memory of that page is cleaned up and it's gone. But let me go and actually modify the code. Let me shut this down. And let me uncomment that line of code. In app controller, because this actually adds a kind of a global component called heartbeat. And before I show you the code for that, let me just restart this application. And some of you are yelling out, hey, use hot reload, use hot reload. Well, I love hot reload for the scenarios that it works perfect for. But we're just going to do this now. All right. So we refresh this. I can add another child. And notice now I've got a new behavior. I have a dynamically modified clock, and it just keeps on changing. I didn't modify this over here. Okay, counter as of, oh, and it's here too. I didn't modify the counter controller. What's going on here? And right here, okay, I have a heartbeat being passed around. And if I add another child multiple times, it is being changed for all of them, okay? And all of them have different state. Now, this is in the counter controller. So let's go look at what that looks like in the counter controller. All right, counter controllers over here. Pretty simple. This is all the code that there is for the counter controller. And look at this. I have listener of application heartbeat. That means I'm listening for this model. All right. If I were to if I were to kind of jump into it, application heartbeats right here. That's all it is. It's time. It is a IUI bus event, and over here, IUI bus event. And if I go back, because I've implemented that interface, that iListener interface, then I have a handle method right here. All we're doing is say, hey, view.time, which is a property of the counter view, just go ahead and do it here. And because I'm in Blazor, and because the controller class is a component, there are some things where because I didn't set a property inside one of the Blazor lifecycle events, I don't get state has changed automatically. I have to call state has changed. So I can do that. And then look, go over to counter view. Time is one of my properties, and it's right there. And so every time that the time changes, it's because this method was called. Well, how is that method being called so many times? Well, it's because in my app controller, which by the way, app controller is global to the application. It's not even the layout. This is the app controller. I'm adding a heartbeat. And so my heartbeat controller is right here. And notice there is no accompanying heartbeat view. The heartbeat controller has no need for a view. It's only behavior. Think of it as a component that has no UI, but because we've separated out the concept of a view from a controller, well, now we have controllers as classes that can do things that are Blazor components. They can do things in a Blazor application, but unless they want a view, they can just live inside the application and listen for things and do things, but they're not even a visible element of the application. And so this is all it is. On a timer, we're going to basically look at, every 1 second. You could obviously configure that and pull from configuration, but we're just going to send a new application heartbeat, and we're going to call it bus.notify. That's all we're doing. And the bus is going to just any of these components, the controller component, any of them that have registered, they're going to get it. Now, if I go to, I'm just going to now drill down just to show you how this works. If I drill down to controller component base, and I'm not going to use my ReSharper shortcuts, but if I go to definition of controller component base, just to show you that, notice we do have this generic form of the class, but if I go up here, I just have events. I'm just kind of mapping those events, but this isn't where it is. I'm actually going to go up one more, a shared MVC component base. Okay. Now, before I go, some people are thinking, oh, what's all this crazy code? This is the render fragment code that allows the view to be encapsulated inside the controller component and have all of the lifecycle events mapped up properly so that the controller and the view work well together, and so that the controller can do things based on the view's lifecycle if it needs to. Again, the view is not aware of the controller, but the controller is aware of the view. So MVC component base, well, you might have seen that, because if I go to heartbeat controller, well, that's the base that it derived from. The heartbeat controller, think of it as a service worker inside a Blazor application. It has no need for this notion of a view. And so there's no separation of controller and view. It just is a thing. So we're going to go to the definition of MVC component base. We have logging kind of integrated right in. We have the UI bus. And so on initialized, you can see down here, on initialized, we automatically register ourselves. So that happens automatically just by using BlazorMVC. All of your controllers are registered on this bus. And then upon dispose, we get unregistered. So things clean up. So as we go back to, I want to look at the home screen. As our highlight of the last time, and this add another child button. Okay, if we If we refresh this again, add another child. It's really interesting. So if we go back here and go to index, add another child. Now, this is an example where your regular Blazor components can work very easily with BlazorMVC components without tripping over each other. So you don't have to have your entire Blazor application use BlazorMVC. You can introduce it and just have one of your components refactored into a controller in a view. And so we see this button has on click of add another child. And all we're doing here is we're calling fragments, which is a collect or a list of render fragments, because that's the language of Blazor, of how you dynamically add things to Blazor applications. And we're going to add counter controller. Now, we don't call the constructor on Blazor components. And remember, a controller, a Blazor controller is a component. We don't call the constructor. We have to ask the Blazor framework to render it for us. And so we have a helper built into the BlazorMVC framework called fragment builder, and then get render fragment, because we just have to have that type. And then if we just put it right there in the view, that's where it goes. Blazor knows exactly what to do. So BlazorMVC also includes these helpers so that you can dynamically modify and add and piecemeal assemble your Blazor screens as you want to, when you want to. You don't have to lay everything out in advance. You know, a lot of times before you don't want to even show the rest of a screen before somebody clicks on a button. And then based on what they click, you decide what you want to render. So that's another example where separating the decisions about what to do is important from the layout. Okay, so let's switch back to our screen. Okay. All right, so you can get BlazorMVC from nuget. This is kind of an old screenshot now. We've got a new version, or no, this is the .NET 6 version. Quite a few more downloads. We're not even advertising this because the goal isn't to get everybody to adopt a NuGet package or an open source. The goal is to teach you about a pattern. And with open source, it's such a good teaching tool. If it's better to maybe use the code for reference or steal some of the code and just use it in your own application, then the license provides for that. It's easy, you know. If you copy the code directly, it's just a little tiny attribution. Oh, I got it from here, and leave that in the source code, and you're totally within your rights to do it. It's easy. So my goal for you is that you're able to have sustained productivity through your Blazor development. You're able to increase quality of your Blazor applications, and ultimately introduce architectural elements which keep the application simple over time. So let's review. MVC, I've said, it's an old pattern, but it's reliable. Use it. And a lot of you have WPF or WinForms or Xamarin projects as well. Separate your view code from your controlling code. All right. Use it. You're going to have complex screens. You're going to have dynamically selected views. You're going to have components within a screen that need to communicate with each other. And you're going to need to dynamically build up screens based on what the user is doing, based on how your screens are designed. And the controllers, those types of code files, those types of objects, they should have the responsibility of interpreting user actions, not just first time load, how to load things for the first time, but they should be in charge of interpreting user actions. So I didn't show this, but the best way to interact is not by having the view have an event handler and then tell the controller what to do. Because remember, views don't even have a reference to the controller, but it's for the controller to create a delegate to one of its methods and then just pass that to the view, so the view can bind the controller's method directly to a button. Okay. All right. And then finally, views, be strict about this. Views should only format the data that's on the screen. Okay. We hope this helped. I think that I was able to answer a lot of questions in line. Before you go, don't forget to grab a free ebook if you haven't already received it. I will leave up my email address here on the screen. I love answering questions. We are going to get more Blazor information out there in written published form. A lot of you have our DevOps architecture poster. We've done other webinars, a lot of them on DevOps and Octopus Deploy and Azure DevOps, Azure Pipelines, GitHub Actions, even database migrations and all kinds of interesting architectural topics. But if you haven't seen all of those, we have webinar archives. Send me an email with any kinds of questions. If you have any ideas for what would be a great webinar in the future, our developer community that we have here at ClearMeasure loves suggesting and asking for topics, and I love doing these things. So thank you for your time. It looks like we beat the clock just by a few minutes. I really appreciate each and every one of you, and until next time, keep shipping.